We're using inverse trigonometry rules in order to find theta, or the size of the angle this time. So we have our three normal trigonometry rules, and we had a chat about making them so that we can just find theta by making those rules inverse. Okay, so we're going to use this triangle with its right angle in order to find the size of the angle. So the exact same process happens. We've drawn our triangle. We need to label our sides. So this one is opposite, this one is touching it, so it makes it adjacent. I can write out my information. So my opposite side is 12, my adjacent side is 10.4, and it's the confusing part now is that theta is the one we don't know. All right, and it'll be in degrees because it is an angle, keep in mind. So the exact same process happens. I go, all right, I've got an O and an A. That fits what looks like tan. So I'm going to write my tan rule down first of all. But I know that I already have all the sides, so I need to use this inverse rule. So theta equals inverse tan of opposite over adjacent. All right? We can now substitute all our values in because we have them. We obviously don't know what theta is yet. Tan or inverse tan doesn't change, but we do know that O is 12, and we do know that A is 10.4. So I can then actually get out my calculator and figure out, all right, where's tan? Tan is over here, and if you have a look up the top there, inverse tan is just above it, so I'd need to press shift or something like that. Okay, so shift tan will give me that inverse tan on the screen. It actually opens the bracket for you, which is really good, so you can see that. So I can then type in 12 divided by 10.4, shut my brackets and press equals, and I will get a number there, and it's 49.0. And if you have a look, let's practice rounding. I want to write my 8 because I want to do 2 decimal places, but this next number is 5, which means it's quite big. So it's going to change this one because it's going to round it up. So 49.09. We have an answer, but we've got to make sure that we understand that it is in degrees because it is the size of an angle. So the size of the angle in this triangle now is 49.09 degrees, or approximately 49 degrees.